discuss about an important technique of separation of the DNA. Actually, it is again a purification technique of DNA also. That is called as Agarose Gel Electrophoresis method. Extensively widely used technique in the molecular biology or the recombinant DNA technology to separate and to purify the DNA sample. Right? So this Agarose Gel Electrophoresis is extensively used in molecular biology to separate and purify the DNA. This technique was proposed and explained by Vesalius. First proposed and explained by Vesalius. The principle of this technique is very simple: the separation of the DNA fragments based on the density gradient. So separation of DNA fragments based on density, you can say that is the mass of the DNA. Right? Steps of Agarose Gel Electrophoresis. Certain steps will remain same as the same steps of the gene cloning. First, we have to isolate the genetic material, that is DNA. Right? After isolation, the next step that we have seen is restriction digestion, that is also called as RE digestion. After RE digestion, what we have received is the smaller fragments, or let us write only we have received fragments of DNA fragments of variable length, of variable size, length, like small size fragments, larger size fragments also. Right? Now what we have to do is, within the test tube or within the tube, we have this sample. Whatever we have get is RE digested sample. Right? This sample we have to use for the next step of Agarose Gel Electrophoresis. Right? For this Agarose Gel Electrophoresis, we need to prepare a thick slurry, a matrix, and as the name suggests, it is made up of agarose only. Right? So preparation of agarose gel. Basically, what we do is, generally the concentration of the agarose gel which is used in most of the molecular biology experiment is 1% agarose gel. 1% agarose. That means we will take 1 gram of agarose and we will dissolve it in 100 ml of distilled water. Right? We will heat it, because it will not dissolve just by simple stirring with the glass rod. Heat it, let it cool to, let us say, 50 degrees Celsius. Touch it on your skin. If you observe that it is more hot, then allow it to cool. Once you see that it is cooling, directly pour in the trough. A space it is given, there is one chamber. A systematic chamber, it is available in the market for agarose, in order to perform agarose gel electrophoresis. Tray is available. Right? In that tray, you have to pour the agarose gel, and after pouring immediately, we have to put comb. Comb is not a normal comb that we use for our hair. It is similar to that comb either of white color or black color it is available, and the extensions that the comb has are very large, like this, right? So this step I am explaining to you. Let us say this is the tray in which you have placed your agarose gel, right? A tray in which this agarose gel has been placed. Immediately as soon as you place this agarose gel or pour this agarose gel within this chamber or the trough, immediately you have to put this comb here. So you have to wait for 30 minutes. After 30 minutes, what will observe? The gel will be formed. So gel will be formed. After 25 to 30 minutes, gel will be formed. Now what you have to do is remove that comb. Once you remove the comb, now you will observe certain structures, because whatever comb structure is there, that same structure will be formed here. We will remove it. These structures that are formed after addition or after removing this comb are called as wells. They are called as well. Now, fourth, what we have to do is simply whatever sample that we obtained as a part of iodization, we have to pour that sample. So, pour the sample into the gel, into the well, right? Using micro pipette, not the normal glass pipette, using micro pipette, right? So, we have poured the sample. Before pouring, one crucial step that has to be mandatorily followed while we are performing Agarose Gel Electrophoresis is we have to add approximately 0.5 ml of ethidium bromide. So this step is before fourth. Add approximately 0.5 ml of ethidium bromide. ETBR means ethidium bromide, right? Okay. Let us now assume that we have loaded the sample. In each well total 5 wells are there, so 5 times we will load the same sample, right? Okay. Now the next step is to the name of the technique is Agarose Gel Electrophoresis. We have understood Agarose Gel Electrophoresis. Electro means electricity, phoresis means separation. So separation of the DNA using electrophoresis, and agarose as a matrix is called as Agarose Gel Electrophoresis. Now we have to switch on the power supply. Right? Approximately 90 to 95 volt is given the power supply, and this power supply is kept on for 50 to 60 minutes. Let us come back to this gel again. DNA, we know it is a negatively charged structure by a macromolecule because of the sugar phosphate reaction. So we are loading the DNA here, the charge will be negative. The negative terminal, negative structure, negative terminal, right? And opposite to that will be positive terminal. That's it. Anions move towards anode and cations move towards cathode. Okay. Now, the next aspect in the Agarose Gel Electrophoresis is we have switched on the power supply 90 to 95 volts, 50 to 60 minutes. We will keep on this moving. Based on the size of the fragment that we have obtained in the early digestion, the DNA will move. Here, smaller size fragment faster, right? Smaller size fragment will move faster because the size is very small. There is no hindrance within the agarose gel. The porosity of the agarose gel is there, right? That's why we use 1% agarose gel. So pores of variable size are created. So smaller size fragment will move faster, and the larger size fragments of the DNA will move slower, right? And the movement is observed in the form of bands. We'll observe various bands, right? Let us say if this is the well, then the DNA moves till here as well as here. It is moving till here only, till here. It is moving till here. It is moving till here. So you can see the maximum band that we observe is till here. That means this well, that is the fourth well, has the DNA fragment of very small size, right? Now the bands are obtained. How to visualize that band? Ultimately, we have to see the DNA and then we will extract, we will elute out the DNA, and further we will amplify using PCR. So, sixth is analysis. Analysis of DNA bands. There are two methods in which we can analyze the DNA bands. First is UV exposure. So what we basically do in the UV exposure is we expose the gel in the UV chamber. UV light has been poured. So expose the gel to UV chamber, right? And if you remember, we have added ethidium bromide. Ethidium bromide. This ethidium bromide is basically acting as an intercalating agent which chelate within the DNA. And when UV exposure, when the UV light has been exposed onto this gel, the DNA fragments appear, or the DNA bands appear as a orange color. So orange color bands are observed, right? So this is the first method. Normally, nowadays, ethidium bromide is added during the preparation only. During the preparatory phase, when we are preparing the sample for the RE digestion, once we have received the sample from the RE digestion, immediately we add ethidium bromide and start the experiment. Right? Earlier it was, or many people used to do in some different way. They do not add ethidium bromide first. After all these steps, when the bands has been obtained, they pour ethidium bromide. So they pour or flood the entire gel with ethidium bromide, right, and expose directly to UV. So orange color bands are obtained, right? But this first technique is used extensively widely. That is, during the preparatory phase, ethidium bromide is added. So literally you can see the bands of orange color, right? Wherever DNA is there, the orange color bands are obtained. So orange color bands are obtained. You can see the bands like this. These bands you will observe only when you connect your gel. That means ultraviolet chamber must be connected to the PC, right? It must be connected to the computer, and within that computer you will observe the image of the gel. Okay, so this is the first method by which you can analyze the DNA bands. Okay, the second method is based on X-ray film method, right? So it is X-rays. Here in this method, radio labeled probes are used. Radio labeled probes are used. Radio labeled probe. Probe is basically a sequence of nucleic acid, nucleotide sequence only, corresponding to the sequence of the band that we have obtained in the gel. So wherever the complementarity sequence is found, the probe will go and bind to the DNA, and then it will appear as a dark band within the X-ray film. Say for example, let us assume this band, right? The sequence of this band is GAATTC, right? The DNA sequence. So corresponding sequence of the probe will be CTTAAG. So wherever GAATTC band is observed, the probe having sequence CTTAAG will come bind to that particular band, hybridize with it, and it is observed directly in the X-ray film as a dark band. So from there, using a UV exposure method as well as X-ray film method, the analysis or the visualization of the DNA fragments can be easily done. So these are the two methods which are used. Normally, people generally used UV exposure method, right, in order to visualize the DNA fragments. Now, one additional thing, or you can say it is an important technique, which is called as a transfer assembly. Before that, we will discuss elution technique, right? DNA has been obtained, we have analyzed. We observe the location of the DNA in the PC, computer. Orange bands are observed. Now we will scrap out the DNA of our interest. So we will scrap out the DNA, that means we will literally cut the DNA from the band, and using the buffer we will elute out, and this process is called as elution. After elution, people obtain elute. Whatever elute, that is DNA sample we have observed or we have obtained, we can amplify this DNA using PCR method, and we can further use in recombinant DNA technology. Right. So this is all about